My name is Carly. I got into Python programming about 2.5, almost 3 years ago. And this series of videos is going to be basically an introduction to Python. So it's really geared more towards the beginner than someone who's already, well acquainted with the Python programming language. And it specifically is going to focus on the basics of Python. We want to build a foundation of Python components, Python uh, structures, Python techniques uh, that's just in the basic Python language itself, okay? And we're going to use Anaconda and its flavor of Python that it installs. There are many flavors, but this is the one we'll use. And then we're also going to do Tkinter, or some say Tkinter, but which is it's built in to the Python programming language when you install Anaconda in Python, and you can create graphical applications with it, GUIs. We're going to limit ourselves to just the basics, even though it's tempting to go out there. There's hundreds of modules that you can pip and install in and use with Python. But the goal of this series of videos is to lay a foundation, right? To create a foundation. And then once we've created that foundation of basic Python, and that foundation of basic Tkinter, we can go in and we can use other GUI toolkits. We can use Pygame to make games. Uh, Nobody's gonna write a best-selling first-person shooter in Python. It just doesn't have the power that C++ or C has uh, in modern game engines. You don't have the control over memory that you would have with that language. But the neat thing about Python is it's sort of like a universal programming language. Almost everyone is beginning to speak a little bit of Python. And the cool thing is, a lot of game engines you can script in Python, such as the Unreal game engine. You can actually script that using your Python. So what I recommend is limit yourself, restrain yourself to focus on Python. Focus on the basics. Build your foundation. And once you've built a good foundation in Python, then add your walls and your fancy windows and your fancy doors and your roof. But if you don't take the time to build a good foundation and you jump into all those other things, well, you know, you, you might find your house crumbling down. Do you want to build your house on the rock or do you want to build your house on the sand? A little bit of Python's history. It was originally developed by Guido van Rossum in the late 1980s and officially released in 1991. It is the offspring of the ABC programming language. In many ways, if you're familiar with C or C++ or Java, it follows similar structures because it's object-oriented, and it has a similar syntax. Guido remained Python's lead developer until July 12, 2018, when he stepped down from the project. In 2019, Python's core developers elected a 5-member steering council to lead the project. Python owes its name, in some part, not to the serpent, but as an homage paid to the British comedy group Monty Python. As a result, Python used spam and eggs in place of foo and bar, whereas a lot of languages use foobar. Python's uses include distributed development, server and client-side scripting, web development, robotics, household appliances, mathematical applications, and much, much more. Python is platform independent, a bit like Java. Remember how Java used a Java virtual machine? And you could install that on any operating system, and the same Java code would, through that Java virtual machine, do the same thing on Linux or Windows or other operating systems. Python's the same way. It runs through an interpreter that you install. So your Python code will run in Linux, and that same code would run on Windows or another operating system. It is platform independent. Um, it's interpreted, so it doesn't need to be recompiled every time you change it or modify it. And there are pros and cons to that. It can, however, package bytecode with dependencies into executables and binaries with package managers used and installed with pip. That's sort of a package management tool that you can use to install hundreds of different Python modules. Some tools for this are AutoPy2exe and PyInstaller, and we'll go over this in later videos. Let's talk about versions. The most recent version of Python at the time of me making this video is, I believe, 3.10.9. I personally prefer installing the Anaconda version. There are lots of different flavors out there, but Anaconda seems to be one of the easiest to use and to get started with. I will include links below to Anaconda's website where you can download Anaconda and install Python. And then as an integrated development environment or a software tool that assists you with programming with things like autocomplete and IntelliSense and syntax and debugging, we're going to use the free Visual Studio Code, which not only does Python, but dozens of other languages as well. And I'll include a link to download that as well below in the description. Also, I've made 2 videos on setting up an integrated development environment in Linux Ubuntu and setting up an IDE also in Windows 10 or Windows 11. I'll put those links below. So to get started, you can follow through with those videos and set up your Python programming environment, and then you'll be all set to go through these videos. Let's talk about indentation. Unlike other languages that use curly braces, such as C++ and Java and PowerShell, Python uses indentation to define a block of code. So it defines scope, what's in a function, what's outside of a function, what's global versus what's local. All of this is based on indentation. With other languages like C++, Java, your indentation is optional. You can write sloppy code if you want to. You don't have to indent as long as your braces are in the right places. You don't have that option with Python. Python forces you to write neat code because it uses indentation itself to designate scope, to define a block of code and where an object or a variable exists, be it local or global. Garbage collection. Yes, Python has garbage collection, just like Java. Reference counting like C++. Believe it or not, Python has pointers. It doesn't call them pointers. It sort of hides what goes on behind the scenes under the hood, but it's capable of indexing objects in memory on the heap or the free store, as well as the stack. It's capable of passing by reference, as well as passing by value and making copies. If you have developed in C++, one of the things that you will appreciate about Python is that it too makes use of passing by reference instead of value for greater efficiency and speed. Whereas C++ gives you explicit control over how this is done with pointers and references, Python hides much of it. But you will find that syntactically and logically, many things work in Python the same way they do in C++ development. You can create an inheritance hierarchy. You can create polymorphic structures and write classes to encapsulate what an object is and what an object does, just like you could with any other language that's object-oriented. You can instantiate objects from your classes that persist in memory, and you can set up a global variable like a pointer to point to that object and have it persist in memory as you go from one function to another without having to pass by value. A lot of the same things that you could do in Java or C++. Is Python truly object-oriented? Yes. Python provides classes, inheritance hierarchies, polymorphic structures, encapsulation and code reuse, exception handling, all the features we would expect of a modern object-oriented language. Is it structural? Although OOP is the path to the future, Python can also be adapted to structural programming, if that's what floats your boat. In these examples, I always terminate my statements in Python with the semicolon. You don't have to do that in Python. Like Visual Basic, you can just write a statement on a line and hit return and go to the next line. You don't need a semicolon. I just carry that over from C and C++ and Java programming. It won't hurt if you terminate a line with a semicolon. And if you do that, you can add more than one statement of code per line. Uh, and it just makes it easier for me to follow, just coming from a background of C++ and Java. So just be aware, if you see me do this in these examples, terminate my statements of code on each line with a semicolon, you don't have to do that in Python, but it's optional. You can do that if you want to. Now, one of the first things that we're going to do, we're going to write our first Python program, okay? And it's traditional to write hello world when you start learning a new programming language. And I've been through this several times, each time I learn a new language. So we want to open Visual Studio Code. And again, if you will, if you don't, if you're unsure what you need to install or how to set up Anaconda and Python and Visual Studio Code to get ready to program in Python, uh, see the links in the description below and go through those videos depending on what operating system you're using, and it will walk you through setting up your development environment, okay? But I'm going to create a new file, okay? And you use the pound symbol to designate a comment, okay, in Python. So I'll call it first Python program ever. If this is, you're just starting out. Now, the color coding's off because Visual Studio Code doesn't recognize this as Python yet, okay? So in order for that to happen, we're going to click File, we're going to say Save As, and we're going to save it as a Python file with a .py extension. See down here where it says Save as Type? So we're going to go over here, and let's pull this down. And let's go find Python. All right, so .py. And I don't want to, depends on your operating system, that may or may not be an illegal character, but we'll call this our first Python program ever. And I'll just click Save, okay? Notice the color coding changed. So it went from that kind of off blue or aqua to green. So that's typically the color of a comment tag in Visual Studio Code for a Python app or program. Now, Python has a very useful function for outputting text and data to the console, and that is the print method or function. And it's just simply print. And like every method or function in Python, uh, it takes parameters or arguments inside parentheses, okay? They're parenthetical. And you don't have to put a semicolon. It's just my style. I carry that over from C++ and Java. And then if I wanted to, I could have two print statements on the same line uh, because of the semicolon, okay? It's just sort of a habit. But just be aware that if you prefer, you could do it like that, sort of like Visual Basic. It's up to you. I just like the semicolons. And that way, when I'm looking at hundreds or thousands of lines of code, it's easy for me to see. That, for me, is an easier to spot delimiter than just white space or just, a carriage return or a line feed. I like those semicolons, but it's totally optional. Okay, so hello world. Okay, we're going to say hello world. Now, if you haven't set up your Python environment, or if this is your first time, you're probably going to get PowerShell. You might not get the DOS, the command prompt, uh, but you can hit Control-Shift-P and just type in profile and search for it. So if I went Control-Shift and P, and then if I were to type in profile, and then you can choose select default profile. So look, you can choose the PowerShell, and you can run your Python through the interpreter, and it'll display in a PowerShell type prompt or terminal, or you can run it in a command prompt. I just prefer the old DOSy looking command prompt, so I set that as my default, but it's entirely up to you, okay? Now to run this the first time, I'm going to click on Run, Start Debugging, and notice it displays Hello World down here. I'm going to insert, this is called an escape character, \n. And in this case, that just adds a carriage return or a line feed, and then another \n, just to add a little space down here. Now watch, I'm going to run it again. And this time, instead of clicking on Run, I'm going to hit F5. F5 is a shortcut key. When you're debugging, when you're writing code, it's faster to do that a lot of times than to click on Run and then a second time to debug. So I hit F5. And see how it just added some extra lines there and hello world. So escape characters, there's lots of them. And it depends, you like in the argument or the parameter where you pass something into the print method to display something on the console in Python, that has to be inside of double quotes. So how do you use a double quote? The problem is if I wanted to just add a quote here, you see how the color changed and see how it's red here? That would be a syntax error because that quote is a special character. I can't use a double quote because Python looks at that syntactically. It says, okay, well, that terminates the string that I'm supposed to print in the print method. So to be able to use a double quote inside the print method, I have to do backslash double quote. And it works that way in Java, it works that way in C, it works that way in C++ as well. A lot of programming languages have escape characters or escape sequences, and it's usually some character like in PowerShell, it's like the tilde, or not the tilde, but that little apostrophe looking thing. In C++, it's also backslash, but it depends on the language. But in this case, in Python, it's a backslash, and then that would be an actual double quote, and Python would print that, interpret that as part of the argument, part of the parameter, as opposed to the character that terminates the string. Okay, so this double quote and this double quote, that doesn't display. That just tells Python, hey, this is the beginning and the end of the string that I want you to print. But if I wanted to have an actual double quote, I'd have to use the backslash. Same for a single quote, to add a new line, a carriage return, a tab, a backspace. Okay, all of these are escape characters in Python. And I have a print statement here making use of some of them, and also showing you here's a semicolon and how we can get two statements of code on a single line if we use semicolons. They're totally optional, but just showing you why. So, and this is defined in a function or method, which we'll go over in later videos, but that just allows you to organize your code into like Lego-like blocks or modules, and it makes it easy to reuse your code. So you can do more with less code and reuse your code without having to constantly reinvent the wheel. So we'll learn to write our code, in a modular fashion using functions and using classes to do more with less. But for now, let's run this and notice that we've got some escape characters here. So this here will actually put unpythonic in double quotes, but we have to use the backslash, otherwise it'd be a syntax error. If I took that out, Python would be like, huh? Wait a minute, I terminate the string and then what's the question mark doing there for? So Control Z, let's undo. We've got to have that backslash to make it an escape sequence, right? Okay, so let me pull this up here and I will try to give us some room here. And we're going to clear the screen and I'm going to hit F5 and we'll run it. Okay, so using semicolons at the end of statements is optional, completely unnecessary in Python. It may even be unpythonic, double quotes, but it provides me with an organizational consistency I like that's compatible with other languages like C++ and Java. It's a personal choice. You may or may not wish to terminate your Python statements with a semicolon. Semicolons allow me to place multiple statements of code on a single line, as in the line above. Pythonistas may abhor this optional, personal, particular style, but there is never truly one way to do it, is there? Perhaps innovation comes by constantly questioning, is there another way, for better or for worse? This concludes our very first Python lesson in this series. And if you like this and you would like to continue, please subscribe. Thank you.